So welcome back to another day. We have another problem. This is the third day I've been doing this now, and yeah, pretty much our derivative for today is z of n is equal to 5n3 on 3. This is we're still just applying the powers laws today, the power law. I think I'm thinking tomorrow I really want to move on. We'll still incorporate this into the other questions, just because, especially the power law, I find you do it just about every, like for every derivative you do, there's at least one power law needing to be applied. But yeah, today I decided to mix some fractions in there and irrational numbers and that, but well, decimal, yeah. So this is our question. In past videos, I've been writing the derivative as z dash n, for example. But another, I would say more, in my experience, this is a bit more common. It's also, the derivative is also written like this, dz over dn, and pretty much your dependent variable goes up the top, your independent variable, which is the one that changes from, it's in the function, and as n changes, we're going to get a change in z. And that it's independent from z, whereas z is dependent on how n changes. So that's why they're called that. So our dependent variable comes on the top, independent goes on the bottom, and what this is saying is d, especially in physics you'd be familiar with this, is represented by this, the change. It could almost be change in z over the change in n. Just as acceleration is known as the change in velocity. But yeah, so dz over dn, which now by taking the derivative of this, we write it as d z. However, so you don't always have to write z. I've seen it quite a lot. I don't know how good of a practice that is. It's just that I've seen it in textbooks and that a lot of people do this. They just forget the z and just put the n there. So that's what I'm going to do here. We can break it into its terms, and this is how we're going to work at it. Ooh. As you can see, I'm still getting used to this Wacom. It's taking a bit of practice. D, n, 5, n, 10, 15. This is how you should write it out. You don't have to, when it just comes to like assignment working in that, unless you're told by your lecturer and that you need to, but it's just really a waste of time in my eyes. I'm just writing it here so you know that you can do this. So it's really expanded now. And another thing you usually do is change it to red. So you bring the whole number or just the number out the front. The front of the, well, that one can stay there. That's just going to evaluate to 0. But let's just try to get the same color-ish. Okay. So we bring the 3 over 3 down. As said yesterday, now I'm just going to work at it as I usually do. So we bring the 3 over 3, which is equal to 1. So that becomes 5 times by 1. N, 1 minus 1. Because remember, you subtract 1 from the power or the exponent. Then we have a half with the exponent of 1.5. And 1.5 as a fraction is 3 over 2, which is handy because we can just bring down 3 over 2 multiplied by 1/2 and use a fraction rule to multiply them together. We've got n, and then 1.5 minus a whole, or 3 over 2 minus a whole, will actually end up giving us, I think that's -1/3, but I'll just check. Okay, no, that's actually a half. Ooh, got that wrong. Oh, of course it is. This is -1.5 will equal 0.5. And now 10 over 15 should simplify quite nicely. I'm going to check this time though. So 2/3. So we bring the 2/3 down. So it becomes 2/3 times by 5 n over 2/3 minus 1. Which I think this now will equal, yeah, this here will be, actually I'm not even going to say it. Yeah, it is -1/3. When we evaluate that. Now, 2n, remember how there's the magical secret 1 there? If there's 2n and n doesn't have an exponent, there's actually just a 1 there. It's just we don't bother writing it usually. So that's a plus. That the 1 comes down, so it's 1 times by 2, n, 1 minus 1. And then we subtract for here, since there's no n at all, we times 3 by 0. Right, now in simplifying this, 5 times 1 is 5, but n, 1 minus 1, well, that's n to the power of 0, and no matter what it is, n to the power of 0, anything to the power of 0 is just equal to 1. So that's like saying 5 times 1, which will just end up equaling 5. Now, 3 times 1 is 3. 2 times 2 is 4. And 1/2 minus, when timesing a whole number by a fraction, you just bring the whole number up top and multiply them together. So 2 times 5 is 10 over 3. And now 2/3 over 1, just to -1 over 3. Now plus 1 times 2 is, well, 2. And n, once again, 1 minus, that would just equal 1. So we're timesing 2 by 1, which just leaves us with 2, and then 3 times 0 is 0. So we just leave that out. Let's just simplify this once more. Or not once more, we can simplify it further after this to show the steps. Now, n to the power of half, anything to the power of half can actually just be converted into a square root, into the root of that. So we'll show that. 3 over 4 square root n. Depends how you like it. I prefer this, but I would say this is further simplified this is better. 10 over 3. I don't really think this one can be simplified any further. Correct me in the comments if I'm wrong, so everyone can see. But I'm going to just leave this as so. Now plus 2, and now these two can come together, and we'll order this so that it's 3 over, we'll just bring this out the front, and 1/2. The minus is here, so we go minus 10 over 3, and 1/3, and 5 plus 2 is 7. So yeah, this is what I got. If you got something else, make sure you post it and let me know how and why you got that answer, and we'll go from there. If you've got any questions as to how I got any of this, make sure you post it too. I also posted another video today in my Integral a Day channel. So if you want to practice integration, definitely check that out. I'll just write the final what have I done here? 3/4. I just converted it back. Good thing I wrote that again. The square root. 10 over 3. Yes, I don't work at these questions before I do these videos, so the point is to just work it through with you guys and sort of document my progress in learning this at the same time. So as time goes on, I'll hopefully get a lot better with you guys. I'm not doing little screwing little things up, but this looks right to me. But yeah, have a good day, and I'll catch you all here tomorrow for another video.